Hello everyone, and welcome to the second lesson of the slightly advanced Python course, in which we're going to discuss inheritance and compositions. Both of these topics come from object-oriented design, and we're going to work with classes today. First, we're going to look at these concepts visually, conceptually, to understand how they work in theory, and then we're going to look how we can implement them in code. So first, let's start with a diagram, and let's start with inheritance. Both inheritance and composition is a relationship between classes. We already know how to implement classes, but we don't know how they can interact with each other to share some functionality or maybe share some properties. And that's where inheritance and composition comes in. A very useful scenario to think about is, imagine you have 10 different classes and you want all of them to share a certain property, right? And obviously one way you could do it is each class would have that property defined inside of it. But that's just a bad practice, because if you wanted to change that property, you would have to find every single one of these classes and you would have to change it. And if you forgot one of them, in best case scenario, your program would break, which would cause you more time to find this bug. And worst case scenario is you wouldn't even notice it, and you would have a program with a bug in it which you are unaware of. So having this common property defined in a single place where you can edit it if the need arises is very useful. So on this diagram, what we are looking at is a very simple inheritance structure where a parent class person is inherited, has two children, student and professor. So the way you can think about it is, person is a parent class which defines some common properties which are going to be shared between all people, all persons. And student and professor both inherit from the person. So both student and professor are going to have all the properties and all the methods defined in person. So in this case, in this diagram, there are no methods displayed, there's only data, but it will work exactly the same for methods. So the person has a name, a phone number, and an email address, which means the student will have a name, a phone number, and an email address as well. And the professor will have a phone number, a name, and an email address. But both of these have some unique properties which will not be shared between them. So a student will have a student number, what classes they are taking, and the tuition fees they're paying, while the professor will have a unique staff number and salary. So professor is a person, student is a person is not a student, person is a parent of student, person is not a professor, person is a parent of professor, and most importantly, student is definitely not a professor, and professor is definitely not a student. So that's the idea behind inheritance. Classes inherit some properties from parent classes, and they can use it within their own class. And obviously, this is just a very simple example. You could add another child and below student to be like a math student and a computer science student, or an arts student, and maybe there's some specific information we would want to store for those as well. The same for professors, and so on and so forth. Now let's actually have a look at how we can do that in Python. And let's go back to our atom. So we already know how to define classes, right? We use a class keyword, we choose a name for our class, we define its constructor method, and we add some methods to it, which we're going to use. So this is a very simple person class. It will have a name, a phone number, and an email, all stored in its constructor method, and it will have a very simple print person function, which is going to print out all the information we have about that person. So let's see that working, and let's comment out everything else for now. So we created a single person, we passed all the information to its constructor method, and we printed the person using print person method inside our class. And all the information we passed was printed. So now, how do we actually inherit those properties in different classes? And the way we do that is using this notation, open brackets and the name of the class we want to inherit from. So we are going to create a class student, which is going to inherit from class person. And for the time being, we're just going to use pass keyword. What pass keyword does is it says we don't want to redefine anything. This class is just going to be exactly the same as the parent class. And let's see how that works. We are going to create a student, which is going to be an instance of a student class. and we're gonna pass it all of these methods. But we don't have a constructor in our student class, so how will it work? And we definitely don't have a print person method in our student class, so where is it gonna call from? Well, let's see. And as you can see, Nick Barnes and all of his details was printed out using the print method function, a print person method, which was defined in its parent class. So actually, when we created a student, it is an instance of a student, but a student inherits from a person. So when we called print person, what Python does is it goes to student, it checks, do we have a print person in this class? No. Well, do we have a print person in the parent class? Yes. And that's the code we're gonna execute on line 36. And exactly the same for professor, just to demonstrate that we can have multiple classes inheriting from the same class. In Python, you can also inherit from multiple classes, but we are not going to discuss that just yet because it gets a bit more complicated. We're going to create a professor and we're going to print person for professor. And as you can see, everything works as expected. We got 3 people printed. One is of type person, one is of type student, and one is of type person. And all of them share the same print person method, which was defined in the parent class right here. Now we have figured out, we have defined how to share properties. Now what if we wanted to have some unique properties in our children classes? What if we wanted our student to have some unique information? Well, we can do that as well. Let's uncomment this and let's remove the pass keyword. So now by defining methods in our student class, we are introducing new methods, but if they are the same name as the methods in the parent class, what will happen it will override those methods. So as we can see, the constructor method is the same in each class. It has the same name in each class. So by defining a constructor method in our student class, we will override the constructor from the person class, and this will execute when we construct a student on line 33. And let's have a look at what we defined it to be. So it will take name, phone number in the email, the same as its parent class, but it will also take a student number, which is unique. Then we're gonna use super double brackets dot notation. What it does, it will call the parent class, and it will use the init of the parent class. So basically, super function calls the parent class instance, and we'll pass the 3 first variables. So line 14 will execute this function, and then on line 15 we add another data point to our student class, which is unique to our student class actually, which is the student number, and we're going to store what was passed to us. And let's see that in action. We have to pass some more information. Q1234, let's say that's the student number of this particular person, and we will implement another method called print student number. Which is going to be called here. Let's comment out professor so that they don't interfere with this for now. And that's what we get back. Let's comment out person as well. And let's clear all of it because it's getting a bit more dusty. So now we have printed all the information of the student using the print person class, which was still defined in the person class. But we also called the method that's unique to a student. This one, print student method, print student number, and the student number was printed. And just to show you that this method is unique to a student class, let's try to call it from a different class which doesn't inherit it from a student. So person1 dot print student number will cause us an error because person has no attribute print student number. This method is unique to a student. And the same for a professor. Let's clear it again so that it's easier to see. And the same for a professor. We get that professor doesn't have an attribute print student number, which is expected because student number, print student number is a method unique to a student and we didn't share it with anyone else. And obviously we can do the same for professor. Let's uncomment all of this. Professor is going to have a unique staff number and we will have print staff number for professor. Let's comment out our student so that it doesn't get in the way. Let's run it. And we get an error because we forgot to pass a staff number to our constructor method. And let's say it's going to be P6543. And let's clear it and run it again. And now this is what happens. And we get print person and we get print staff number. So this is what I wanted to show you. Each class, student and professor have some common properties. In this case, it's this function, and they're both also calling this super function in their constructor methods to store information, common information such as name, phone number, and email. But they also can define their unique properties such as methods and such as data. And it's also going to be unique to them unless something below them inherits it from them. And so on and so forth. You get the idea. Obviously, you can nest it as much as you need to. There are many scenarios you can use it for. You could maybe store items in a shop in this tree-like structure. You would have a shop item at the very top, and then you would have like called items or closing items branching off from it. And they would all have something in common, and they would all have something unique about them. You could also store some vehicle information. So vehicle would be a top class, and then you would have like cars and trains and planes, which would all be children, and they would all have something in common. For example, number of wheels, but they would also have something unique. For example, a plane would have a wingspan, which we would need to store and something like that. So you get the idea. Now let's look at composition, which is the second relationship between classes we're going to look at today. And let's get back to our diagram. Let's actually remove all of this. Can I just not move you? Yeah, I can. And let's bring a composition back. And let's move it out of the screen so it doesn't bother us. So what is composition? Composition, again, is a relationship between two different classes, but instead of one class being a child of another, now we are saying, okay, class number A will have class number B in it. So in our current example, we have class person having address in it. So we will actually add it here. Address. And now class person has an address in it. And unlike name, phone number, and email address, all of which were strings in our person class, address is actually a completely different class. So of course we could literally just add street, city, state, postal code, and country to our person class, but it would become really cluttered, and it is much more logical to create this hierarchical structure where we just say, okay, a person will have an address, and then we will have a look at an address class to see what an address actually is. And in an address, we will define the street, city, state, and postal code and country. So as you can see, this is very different from inheritance because a person class just has address in it. It is not an address. It still has name, phone number, and email address. And the same, likewise, address is just a class we're gonna put into other classes where needed. It doesn't share anything with person. And now let's look at the code to see how that would work in Python. Again, back to Atom. So first we are going to define the address class. It is defined as such. There is nothing special going on here. So there's just a constructor method which is going to take all the needed information to construct the address class, like street, city, state, country, and postcode. And we're going to have a print address method, which is just going to print it all in a user-friendly manner. And then we're going to construct a person class, which is exactly the same as what we had in inheritance.py. The only difference is now we actually have self.address equals none. So when a person is constructed, it will have another data field called address, and by default it's going to be there's nothing is going to be stored in there. But the other difference is when we print the person, we will actually also print the address. We will call the print address function of the address stored for this person. And let's see how we can use those functions we just defined. So we create the person exactly the same. We pass their name, we pass their phone number, and we pass their email address. But now we also create an address. You see this is an instance of an address class, and we pass all the needed information to construct an address. We add some random address in London, which probably doesn't exist, but it's alright for the testing purposes. Royal Street, London, Greater London, England, AB1, C34. And we store this address we just created in the address field of our person class, person instance as such. And then we will call print person. And let's see how it works in action. Python 3 composition. So it printed all the data we had about the person, this line. It printed its name, their name, their phone number, and their email. And then line 23 executed self.address.printAddress, which called this method on line 11 and 12. And that printed all the information regarding the address of this person, which is Royal Street, London, Greater London, England, AB1, C34. So you can already notice some differences between inheritance and composition. And obviously you are beginning to question and ask yourself, well, which one is better, which one we use? And the answer, as it is commonly is in programming, is it depends. Whether we use composition or inheritance depends on the scenario we are currently working on, and most commonly we will actually use a combination of both in order to achieve the desired outcome. That's why I preferred a third file, where we actually have both of them together, both inheritance and composition. So the address class is exactly the same as we just looked at in our composition file. It's exact copy. The person class is an exact copy of this person class. Again, it has name, phone number, email, and an address. And the print person was slightly updated to also print the address when it is called. And now let's have a look at how we can use it. We will create a address, same as in previous example, and we will store that address for a person, just as in previous example, but we will also store this address for the address field for a student instance and for a professor instance, and then we will call print person for both of them. And let's see how that works. Print/n, by the way, just creates a new line so that it looks slightly nicer in the terminal, but it doesn't affect the running of the program. So what happened is print person was called for the person one, for student one, and for professor one. For person one, it worked as expected. So person details were printed and address was printed. And for student one, it worked perfectly as well, because student inherited it from the parent class. And for professor, obviously, as well. Obviously, we are using the same address for all of them. They would have different addresses in a real life scenario, but just for the sake of example, this works as such. And obviously, if we wanted to have some unique properties, let's bring back this, print student number, and let's comment out professor so that it doesn't interfere. And let's run this code. We are getting an error because again we didn't pass the student number, key 1234. sorry, not to a person, but to a student. Q1234. And as we can see, again, student's name, phone number, and email address were printed, student's address was printed, and student's student number was printed as well. So this is just a small example showing you how inheritance and composition can be used together, but obviously for a real-life scenario you would look at much more complicated examples. Your class could use composition with dozens of other classes, and then it would be a part of a huge inheritance tree. It could have like a parent, and it could have another parent and a parent. It could be a very big hierarchical structure. So obviously it all depends on the current scenario you're working on. But just as a final note before I finish this lesson, when you're choosing between inheritance or composition, the question you wanna ask yourself and you want to answer is whether you want your class to have a certain functionality or to be a certain functionality. To have or to be is a quick way to remember it, and I'll probably use it in a thumbnail or something. If you want your class to be to be the same as another class, you would use inheritance. And if you want your class just to have a certain property or a certain functionality, then you would use composition. And if you want both, you would use both. Anyways, that's everything I want to talk to you about today. I hope you enjoy it, and if you have any questions, you know how to reach me. See you next time.